Chapter 3. Here we are, 3.1. Chapter 3 is all about functions. The first question is right here, and it's kind of funny. It's a graphing kind of question. It'd be easy, actually. Basically, it's asking you, which of the following are functions? Like, which of these pictures are actually functions?
Something because I know the one that the wave, that's a frequency.
Have you heard of the vertical line test?
Okay.
You heard of that in some of your previous classes?
No.
If every vertical line hits only one point, then it is a function. So it's just kind of a weird rule. Probably doesn't make any sense right now, but it won't be hard for you. So basically, it's called the vertical line test. If every vertical line hits only one point, then it's a function. So how about that first circle one?
No. Not a function.
No way, huh? Because there's a vertical line that hits more than 1 point. So we'd say no on that one. So that's basically the test. You want vertical lines to only hit once. You don't want them hitting more than once. How about the next one? If I do vertical lines on that one, perfectly vertical. It's got to be perfectly straight up and down. They all just hit once, so that one's good. This one's a yes. We would check this box. It wants me to select the ones that are functions. How about the third one? Every vertical line only hits once, so that's good. That's another yes. That makes sense. You want vertical lines to only hit once. How about there's like two more, or we already did this one, huh? This one's already, it's the same one again, yes. And how about this last one?
It only hits one.
Yes.
Yeah, every vertical line only hits once. That's a yes. These are both yes. And there we go. Just as easy as that. Seems weird, I'm sure. Like, why are we doing vertical lines? We'll talk more about it. But first off, that's the rule. You want vertical lines to only hit once for something to be a function. And then oh, wait, there's two more. Yeah, they keep going. Wait, two more. All right, we're still going on number one. How about this one here?
Yes.
Yeah, every vertical line only hits once. That's another yes. And now the last one.
No.
Yeah, because there's some vertical lines that hit more than once. So this one's a no. Not a function. So we don't want vertical lines hitting more than once. If they do, it's not a function.
So the
Rules now for it, because we're going to be getting into it. Same thing here. They also want select all where y is a function of x. Now there's no pictures. Now there's tables. So let me give you the rule in words. So y is a function of x when every x goes with only one y value. You want every x to only go with one y. You don't want an x going with two y's. That's exactly like you don't want a vertical line hitting two places. So let's look down at the table, at the tables. We'll start with the first table here. In the first table, are there any x's that go with more than one y? No, he's good, I think.
no, there's two twos and one.
Oh yeah, and the second one. So this first one's a yes. The second one is a no because of this right here, huh? So this one's a no. So the first table is good. These are four different, perhaps, functions, possibilities. All right, so the first table, that's a function table.
Right, but even though the y has a two twos on it, it's still good, right?
Oh yeah. That is actually still good, yeah. Because actually you can have a repeating on the y, you just can't have a repeating on the x. Right? Because both these guys are going with different same y value, but that's still two different x's.
X's, okay.
Yeah. But no on the second table, because we have the same x value, 2, going with two different y values. Do you see that? What would I, if I graphed that? Let's graph that real quick. I don't mean to graph the whole thing, but if I just graphed 2, 1, That'd be over 2 up. Remember how graphing works? The first number's over, the second number's up. So that'd be over 2 up 1. And what would 2, 6 be? Well, same kind of thing. 3, 4, 2, 3, 4, 5, 6. Over to be like up here. Over 2 up 6. Do you see that those 2 points would be in a vertical line, hitting 2 points? It's the same thing. Do you see the vertical line test is another way of saying every x can only have one y? See how they're saying the same 2 things in different languages? Like me saying 1 and uno. I'm saying the same number in different languages. The vertical line test, or every x can only have one y, that's the same thing, isn't it? In graphical language or table language. They're saying the same thing. That's what a function requires. We don't want an x going to 2 different ways. Because we're saying basically, what does 2 go with? Does it go with 1 or does it go with 8? We can't have that. We can't have an x going with 2 different y values. That's a big no-no. How about the third table?
It's good, but not the last one.
That one's good. The last one's bad?
Yeah.
What's bad about the last
1
one?
and 3 and 1 and
Oh, yeah. 1 goes with 3 and 1 goes, can't make up his mind. Who does 1 really go with? So that one's not a function. Those are 2 ways to say the same thing. Vertical line test, or every x must go with only one y. So that's what it means to be a function. There it was nicer. So anyway, again, this was a no. This was a yes. So I'm just doing the same question again. I didn't realize I had it here. No. This would be yes. And this was, right, because this was a no here. And this was a no here. But this one was a yes. Okay. On to number 3. Now they're changing the game a little bit on number 3. They're speaking of 1 to 1. 1 to 1. I think that's pretty obvious what they mean. They mean 1x for every 1y. So it's got to be 1 to 1 both ways. So in other words, let's just do the new table. So does this look good? Is every...
No.
Or is there... No, there's no repeating at all is allowed. Is there any repeating there? Yeah, it's a problem. We got the 9 going with an 8 or a 15, so that'd be a no. That's not a 1 to 1. So this is even a stronger condition. 1 to 1 function, both x and y can only go one way. Does that make sense? Whereas before, we only worried about x. Only x had to go with one y. But now we're saying x and y must be matched up 1 to 1. How about the second one? Is this one 1 to 1?
No.
No, because we got those 2 y values. How about the third one? Is that 1 to 1?
Yes.
There is a 1 to 1 function. So there's one x value for every one y value. There's no repeating for x or y. Previously, we just said no repeating for x. That's just a function. But 1 to 1, no repeating for anybody, x or y. One value for x for every one value. Everybody's unique. Every x and every y, unique values. All right. And then, now, what do they want us to do here? It says 1 to 1. So now they want us to look at graphs and decide which of these are 1 to 1. Well, what is 1 to 1 on a graph? Well, we've got the vertical lines, only 1 point, right? Vertical lines, only 1 point. That was what we had before. But now we're going to add to it even a second condition, because this is stronger. 1 to 1 is even stronger. So what are we going to throw on in addition to the vertical line test? Horizontal lines, also only 1 point. So now, not just vertical lines, but also horizontal lines must hit only 1 point. So how about this first one? Every vertical line only hits 1 point. That's good. Yeah, but horizontal lines hit more than 1 point. So no, he's not 1 to 1. He would be a function. He passed the vertical line test, but he failed the horizontal, so he's not a 1 to 1 function. He's a function, but not a 1 to 1 function. Does that make sense? Right? See what that horizontal line says? Like right here. I'll put this horizontal line right there. See, that's at a height of 1, and there's different, that's at a y value of 1, there's different x values going with that same height, that same y value, aren't they? How about the second one? Yeah, he passes every test. Every vertical line only hits 1 point. Every horizontal line only hits 1 point. This one's a yes. Good. How about the third one down there? 7 on this page. Yeah, here, let's move here. Here he is on this page. So yeah, he passes both tests too. Every vertical line hits only 1 point. Every horizontal line hits only 1 point. Easy yes. And last, no way. Right? No way on that one. He fails both tests, doesn't he? Good? Pretty easy? Just vertical and horizontal line tests. Both tests for 1 to 1. All right. Oh, there's more. All right, how about this one? Every vertical, every horizontal. Easy yes. This last one, it has a little jog there, but it's good. You might look like there's something going on, but there's really not. That one's okay. That one is okay. It's kind of funny the way they drew it, but it's good. Every vertical, every horizontal line, only 1 point. Those are both good. All right, I don't think that'll be a problem for you. Let's move on to new stuff. How about the plot below represents the function f of x, and they want us to evaluate f of 2. Yeah, this is good. So what do they want me to do? When they say evaluate f of 2, what exactly they're saying? That I'm going to read the answer off the graph. There's nothing actually to calculate. It's just a matter of reading the answer off the graph. So f of 2, the key to reading answers off graphs is to remember that what's plugged inside is x and what it equals is y. So in other words, the x is 2 there. And we want to know the y value that goes with x2 on the graph. So remember, this is the x-axis and this is the y-axis. So let's find the point on the graph with an x value of 2. Do you see it? Right there. X value of 2. What's the coordinates of that point? Over 2, up 4. So that's the point on the graph with an x value of 2, and he happens to have a y value of 4. So they're saying, for this graph, this function, when x is 2, what y value goes with it? 4. So we just read it off the graph. We just find the dot in that spot, and that's all they want. They just want you to find the x value of 2 on the graph and give them the y value that goes with it. Now, how about on the second part? They're asking me for the x, and they're giving me the y. Remember, x is what we plug into the parentheses. That's the key to reading graphs, functions on graphs. X is what we plug into the parentheses. Y is what it equals. So if y is 2, can you find that? Can you find the point on the graph that has a y value of 2? It's right there. Yeah, here's a y value of 2. It's the point over 3 up 2, isn't it? That's the x value, y value. So what is the x that goes with it? Yeah, it's 3. Is that good? Number 6. Based on the table below, evaluate f of 2. So again, remember with functions, x is what we plug into the parentheses. Y is what it equals. That's the key to dealing with functions for graphs or tables, either way. What you plug into the parentheses is x. What comes out is y. So looking at that table, if we put 2 into the parentheses, if x is 2, what's the function value? 2 goes with 86. Yeah. Now notice they're making the table x and f of x. It's also x and y. Y and f of x are 2 ways of saying the same thing. It's the one and uno again. 2 ways. So they'll use that a lot, and it's been used in higher math as well. Y values are function values. They're always one and the same thing. I'll say that many times over the next few weeks. Y values are function values. They're one and the same thing. All right, how about that next part? F of x equals 6.
1.
Yeah, so they want you to find the x that goes with the value of 6. It's right here, isn't it? X is 1 when f is 6. So x is 1. All right. Well, on number 7, if you're good with that, I'll move on to number 7. They want us to actually plug into a function. Have you done this kind of thing before? Let me bring it up here. So, so we have f of x equals 4x squared minus 4x plus 2. And they want us to figure out f of negative 2. So the way functions work, the x is like the holes in the toaster. It's the insert slot, right? So this, whatever is in the parentheses, negative 2, that's going to end up in the x slot. Like so. Are we good to there? Does everybody see what I did? So whatever they plug into the parentheses, you plug into the x slots. See how it went in both those x spots? Right there and right there. You plug in negative 2. And so then we work that out. 4 times 4 plus 8 plus 2. So that's 16 plus 10, 26. So there's the answer to that one. We have 4 more to go. Is that good so far? So I just plugged a negative 2 in for x and in for x to the function, because that's what the x is in a function. It's the holes in the toaster. It's the insert slot. Insert here. So I put in the negative 2 in both the x spots, and then I just worked it out.
So the f and the negative 2 you
Over there. It's saying to you, put negative 2 in the f function, please, and tell me what that equals. That's what it's saying. But yeah, we don't actually do anything on the left after we've been given that instruction. Is that good? Is that making sense? Let's try the next one. Let's try f a negative 1. See if you can do that. It's the same exact thing, the same function, 4x squared minus 4x plus 2. But now put negative 1 in both the x spots. Good, so if we put in negative 1, we're going to get 4 times negative 1 squared minus 4 times negative 1 plus 2. Good to there so far. Now what comes of that? That's negative 1 squared. That's negative 1 times negative 1. Positive 1. Okay, because 2 negatives make a positive, right? Negative number squared is 2 negatives, so it's positive. Negative times negative here, plus 4. And so that's 4 times 1 is 4, plus 4, plus 2, 10. What we're saying.
Because I got,
It's like, here's my favorite analogy. In fact, my kids always kid me about it. If you take a toaster, I know it seems silly, but I want this to make some physical sense. You take a toaster and you put bread into it. What do you get out? You get out toast, right? It turns the bread into toast. That's all we're doing. This is my function, this is my x, and this is my output. That's all a function is. It's like a toaster. You put stuff in, right? You can put different things in. You don't have to put in bread. You can put in frozen waffles.
A bagel.
Yeah, put in a bagel. I do almost every morning. I put a bagel in my toaster and have a bagel cheese sandwich. Yeah, you put in a bagel, you get out a toast bagel. You put in frozen waffles, you get out a toast waffle. You can put different things in, and it does something to them. It does the same thing to everything, and spits out an output, huh? Well, that's exactly what we're doing. We're saying, put in a negative 2 to this toaster, and you get out a 26. Put in a negative 1, you get out a 10. So this left side is just saying what we put in. We don't have to actually do anything over there. It's just saying we put negative 1 into the toaster, out came a 10. Make sense? That's all a function is. So 3 more. How about if you put in 0? That's the next one. So yeah, that'll be an easy one, huh? So let's do that. So next one is f of 0. So we're going to plug 0 into the same toaster, this toaster. It goes into the x spots, and minus. We just work it out. And yeah, can you all see that's just going to be 2? Because the other part's 0, 0, those are just gone, huh? So you put 0 into this toaster, you get out a 2. So that one's a 2. Now let's put 1 into this toaster. F of 1 then just work that out on your calculator. I think it's going to be 2 again, isn't it?
Yeah.
Yeah, because 4 minus 4 is 0, plus 2 is 2. So that's 2. Last one, put a 2 into the toaster. And you get 4 times 2. Oh, is that what it is? Yeah, good job following that pattern. Yeah, that sounds right. Oh, wait a minute. No. Oh, no. It's a little different, huh? All right, so what's that going to be? 16. That'll be 16 minus 8 plus 2. Yeah, 10, huh? 10 it is. How are we doing? Is that good? Yeah, that one is a problem. We'll get to those graphs later. It's a U shape. We'll get to it later.
What about look at those?
What's that? My kid's got a good experience, and I've got one kid that's. All right. So number 8, same kind of thing. We're going to plug into the function the -4 and the +4, and then when we get those two answers, we're going to add them up. Like, I think this is easy if you understand what they're saying. So let me kind of put it in the toaster talk again. We're basically taking -4. We're going to plug it in the function, and we're going to get some answer. Something's going to pop out of the toaster. Take that answer, and then we're going to go over here. We're going to put 4 instead of -4, regular 4 into the toaster, into the function, and a different number is going to pop out. And we're going to take those two answers and add them up. That's what that's saying. It's saying put a -4 in, get an answer. Put a +4 in, so you'll start over again. Put a +4 in, get an answer, and then take those two answers and add them up. That's what that is saying. All right, so let's do it. So let's first put the -4 in there. And we'll see what we get. Whenever we plug in, we put parentheses around what we're plugging into the function. So I'm plugging in -4 in both the X slots, right? The X's are the insert slots, where you plug in the numbers. So that's -3 times 16. Just use your calculator if you want, Work that out. I got -8. I think I get that right. So that's the first answer. That's the first what pops out of the toaster, right? We put in a -4. Out popped a -8. And now we start again, and we put in a regular 4. And we're going to see what pops out, and we'll take those two answers and we'll add them. So we get -3 times regular 4 squared. So what is that? -48 minus, this would be a big negative number, huh? Minus 80, is it -72?
Yes.
So there's our first answer, there's our second answer. And so we're supposed to take those now and add them up, huh? So this one's -8, and the second one came out -72. So, when you're adding, subtracting positive and negatives, just think about money. So if you lose $8 and you lose $72, you lost $80. You lost a bunch of money. So now the second part should be super easy. We don't have to redo everything because, see, they're just telling us to put -4 in the function again. Well, we've already done that. We know what pops out when you plug -4 in. It's just going to be the same. It's going to be -8, right? That's the first thing that comes out. And then they're saying the same thing. Put 4 in. Well, we know what pops out. You get a -72. But this time they want us to put a subtraction between them instead of a plus. See the difference there? So, and that means we're going to end up with a double negative thing, right? Because of the subtraction in the middle, and then both the things that popped out were negative. And so double negative in the middle, you know the deal. That becomes positive, doesn't it? So it's actually -8 plus 72. 64, yeah, 64. Positive, regular, 64. Same kind of thing. Make sense on these functions? What we're doing there? just go back here, get some free space, and I'll just draw them out for you, what they are. So I'll just say, okay, here we go. This U shape, oops, mine didn't look very good. This one is x squared, and so we call it a squared function. And then there's also x cubed. Does anybody know what x to the third power looks like? It does a snake thing like that. So that's called cubed, right? Because third power is called cubed. Cubes are three-dimensional, and squares are flat two-dimensional. So that's why we use square for the word 2, for the number, I mean. We use the word square for the number 2, and the word cube for the number 3. It's just three-dimensional, two-dimensional. That's what we're saying. So it's a cube function. And now, right below them, let me show you what we do with the roots. So this right here is the square root. So we're saying 2 root when we say square root, aren't we? Because remember, square means 2. Square is two-dimensional. And then right below the third power one, I'm going to do a sideways snake, and that is a third root. We call that a cube root. Instead of a square root, a 2 root, that one's a cube root, a 3 root. So I'm just letting you know what they generally look like and what their names are. Now, there's also one that makes a V. Know what that one is? That's absolute value. Have you seen those straight bars? I can't remember if we've gone over those or not. That's absolute value. It makes everything positive. That's why it bounces up, because everything's positive. Absolute value. And let me go see what else they want. I can't remember how many they want. They want 1 over x. And is that it? Am I missing any? Oh, and 1 over x squared. Okay, 1 over x and 1 over x squared. Here we go. So I'll do those two down here. So 1 over x and 1 over x squared. Yes, those are good. So coming down here, these are weird. So this one with the 2 branches, kind of. So that's 1 over x. Yeah, it's called reciprocal because it's flipped. It's reciprocal function. And then right next to it, kind of like it, but slightly different, with both branches. Oh, wait. Did I do that in the wrong place? I did. What am I doing? Doesn't look like that. It's these 2 quadrants. I'm getting too casual. It's those 2 quadrants, right? Yeah, right. Had it the wrong way. All right, and then the other one, both up. This is 1 over x squared. You see, because it's squared, so everything's positive. It's all up. And this is called the reciprocal squared. Because, again, it's flipped, but it's squared, and they're both up. So that's it. So, on the next exam, this will be the next exam, you'll just have these on your 3x5 card. So you'll be ready to go. You'll just have them there. There's the names, and there's what they look like. We're going to be fiddling around with these a lot in Chapter 3. We'll be doing a lot of stuff with these various graphs. So, all right, so let's go back and answer the questions, and it'll be here on YouTube if you missed any part of it. Let's go back here. All right, where are we? There we are. Okay, so get this out of the way here. Okay, so they want us to match these up. So, first off, this one, bless you. What does that one go with? Yeah, that's square root. So right there, so I'll put a C over there. And what about the next one? X cubed? Yeah, that's the cubic. Yeah, E. Cubic. All right. What about this one? Yeah, reciprocal squared. How about the next one? That's 2 power. Is that option not here? Is it somewhere else?
No, it's not square root. It's not absolute value.
Oh, I'm sorry. They gave it a new name. Quadratic. quadratic. Yeah, I'll go back. I don't know why they use that name, but they're right. It can be called that too. So back here, this is also called a quadratic, which probably sounds a little funny. Like quad means 4. Why are we calling an x squared a quadratic? It's because if you have x squared, you can have at most 4 parts. See how there can be an x squared part, a regular x, a number here, and a number. For a quadratic equation, you can have at most 4 parts. So an x squared equation can also have x to the first, a plain number, and a number over there, can have 4 parts. That's why they call it a quadratic. Well, a little funny. So anyway, quadratic or x to the second power. It is good to know they will refer to it that way a lot. A quadratic is an x squared thing. So it's also called squared. So, all right, so yeah, that's quadratic on that. And now, what about this one? Little 3 in the hook there. That's the cube rooter, right? It's a root, cube root. Okay. And then the bars on the x, absolute value. And the 1 over x, reciprocal. Do we get them all? Well, there's one more. Oh, yeah, that one's just linear. I didn't even put him on the list. He's just regular linear. Y equals x. He's going to be a straight line. His graph is just a straight line. So I guess I could add him to the list.
So this is basically what we did in chapter 1 and 2.
We did some of this. Yeah, this is getting a little more advanced, but yeah. There we go. That's y equals x. That's linear. There. So there we go. There's all the different kinds. Now they're going to, on the next page, they're going to have us do the graphs. So remember what those look like, and we're going to match them up with the graphs. Yeah, so there we go. So right here now. So match the formulas to the graphs. So let's start with the, how about we do it this way? How about we just do this guy and we'll put the equations next to it.
That's y equals
Absolute value of x. Because that's what makes it bounce up. Because otherwise, well, I don't want to go into too many details. All right, so what's this one? That's the 1 over x, the reciprocal. This is just the y equals x, the linear. Good so far? All right, this is the same thing again here. Y equals x. Now, what's that U-shaped graph?
Isn't that the quadratic?
X squared, the quadratic.
Yeah.
Called quadratic or x squared. Yeah, exactly. Good. How about that? It's like a sideways snake. Yeah. Notice the ones that go sideways are the ones that have the roots, and the ones that go up and down real fast have the powers. Does that help you kind of distinguish them? Because powers make things happen fast. It goes U-shape up, or right? So see how this goes up and down super fast, and this one goes up real fast. So that's got a power on it. That's how you should think. This one down here has got a power. So this is going to be x to the third. It's got a power. But this is the snake going sideways, so that's the third root. And this is going sideways. What's he? Regular root, which means 2 root. There's really a 2 in that hook, isn't there? The 2's understood. You don't have to write it. It just means a 2 root. It's a square root. Yeah, so you see, so the sideways graphs are roots, because when you root numbers, they get smaller, don't they? It doesn't get big very fast, right? You know what I mean? Like, what's the root of 16? It's just 4. See how it makes numbers small? That's why these functions don't go up very fast. They're pretty flat. They don't come. Whereas if I take 16 to the third power, I don't even know. It's something gigantic. It's like 1,000 or something. So, right, that's why this goes rocketing up and rocketing down if you do negative. Just trying to give you a feel for why they look like they look. So high powers go up and down fast. Roots go pretty much sideways because they don't get big very fast. And let's see, another one. So that's x cubed again. And then what's this one? Yeah, that's the 1 over x squared. Yeah, it's just like the 1 over x has the 2 branches, but they're both up. Why are they both up? It's positive. Remember, if you square something, even if you put in a negative number there, when you square it, it'll be positive 1/9, won't it? See how everything is above, only positive y values? No negative, nothing down here, no graph below the line, no negative, because you're squaring everything. It's going to make it always positive. All right, so there's the names on those. Now, this won't be hard for you. Now they want us to identify them by the table. It's pretty easy. Just look at what's happening to the numbers. I bet you can tell. So like on part A there, -2. So they put into the toaster a -2, input, output, right? Put in -2, and out came a -8. What do you got to do to a -2 to make it become -8? third power, right? Because negative 2 times negative 2 times negative 2, right? 2 times 2 is 4 times 2 is 8, and 3 negatives makes it negative. Remember, every 2 negatives is positive, but a third negative, it'll be back to negative, huh? So that's the third power one. So this is x cubed. How about this next one? What's happening here? How does negative 2 become 2? And negative 1 become 1? And 0 becomes 0, and 1 become 1, and 2 becomes 3. What's happening there?
Isn't that absolute value?
Yeah, see how these are all coming out positive? They're just taking whatever number's on the left and making it positive. That's absolutely right. That's what he does. That's what those bars do. They make everything positive. Good. All right, how about this next one? Oh, they're not telling us the first two. But 0 goes to 0, 1 becomes 1, 4 becomes 2, 9 becomes 3. How does 9 become 3? Square root, huh? Oh, and that's why you can't do square root of negatives.
No.
It's air, it's can't do it. Yep, good. All right. How about this one? How does negative 2 become 4? Negative 1 become 1. 0, 0. Did I miss one?
Yeah.
Oh, I did miss one, didn't I? Yeah, let's do D down here. All right, so how does negative 2 become negative 0.5? Negative 1, negative 1. 0 can't be done. That's a hint. Why can't 0 be done? 1 becomes 1. 2 becomes 0.5? That's 1 over. Do you see that? Try it out for the negative 2. So 1 over, right? You put in negative 2. So if you plug in negative 2 to the toaster, what is 1 divided? Well, first off, it's negative, right? Positive over negative is negative. And what's half? 0.5. Yeah, negative 0.5. See, that's the 1 over x function, isn't it? Plug in negative 1 to the toaster. So we plug negative 1 into the toaster. We're going to get 1 over negative 1, which is just negative 1. Right? All right. Yeah, how about this one up here now? So now 2, or negative 2 becomes 4. Negative becomes 1.
Yeah.
What's happening there?
Squared.
X squared?
Yeah.
Is that what it is? Yeah, looks like it, huh? We're just second powering everything, aren't we? Good, all right. And then F, what's happening on F there? Negative 2 is negative 2, negative 1. They're all the same number. It's X. It's the very same number. It's just X. It's just itself. Do nothing to it, in other words. Just leave it alone as X.
Do we even call that linear?
Yeah, it's linear.
Oh, okay.
Yeah, but they don't want the names. They want that right there on that one. Is that good on those? Playing the identification game? All right, now they're going to come back to, so this is the last main topic. Probably only have time for maybe one of these, because these are long, but they are valuable. So 1 or maybe 2 of these. What do they want to hear? So they're giving us a function on this one, 5x plus 5, and they're wanting us to plug in an a here. So they're saying, take that function and plug in an a. So if I plug in, now remember, whatever's in the parentheses is plugging, it's like it's going into the holes of the toaster, right? You're plugging it into the toaster, and the holes of the toaster is the x. All right, so what do we get? We get,
5a plus 5.
yeah, just 5a plus 5, and that's it. There's really nothing more to do, huh? It's just 5a. We just plug in the a where the x was. Remember, the x is just holding a spot. In fact, let me help you with that. Here's how I like to write it sometimes, which I think is helpful. The function f of x, 5x plus 5, I think it would have been better if math did it this way. Instead of those x's, if they just made that a blank and they drew a little tunnel here. That's exactly what's really happening. Whatever you plug in right here is going to slide down and show up next to that 5. That's what the x is in a function. It's just a blank, really. We call it a dummy variable. It's not a smart variable. It's just holding a spot. That's all it's doing. It's just a placeholder. It's just holding a spot there. So that's all. So if you plug a in, well then, a will slide down and show up there. What if you now, on the next one, we're going to plug in a plus h. So what if you plug into that, the holes in the toaster there, plug into that slot, a plus h, well, a plus h will slide down and show up where the x was, huh? So it'll be 5, a plus h, plus 5, that making sense? And they do want you to distribute on this one. So we'll distribute, so we'll get what, 5a plus 5h plus 5. There we go. 5a plus 5h plus 5. Now, on the last part, they want us to put these two things together. Meaning, first they want f of a plus h. Well, that's this right here, isn't it? That's going to go right there. And f of a is next. Well, that goes right there. Does that make sense? They want us to take the two answers we just got and put them in the top with a minus sign in between. So I'll say, okay, so 5a plus 5h plus 5. That's the first one, right? That's the, here, let me give a little more room so we can see it better. So again, 5a plus 5h plus 5. That right there, that is f of a plus h, which is the first thing they want. Subtract, and then they want f of a, which is right here. 5a plus 5, and then that's all over h. This is f of a. Does everybody see that so far? And then we got to do a little simplification. But you see how I took the answers we just got, put the a plus h on the left and the a on the right, a plus h answer on the left, f of a answer on the right, put a minus sign between them. You do need parentheses around these guys because we're saying this whole group subtract that whole group. That's what the parentheses are doing. Over the h. And now we just do a little simplification. That good so far? That thing we're doing right there is super important if you go the way of pre-calculus and especially calculus. In Calculus 1, that's called the difference quotient. Well, they probably call it that way here, or they will soon. Somewhere down here, they'll call it, it's called the difference quotient because it's the derivative. It's something very important in calculus that you do a lot of. That's why they're showing it to you, getting you ready for it, prepping you for calculus. Are you headed to calculus? They're getting you ready for calculus. So, all right, so how do we work that out? What do we do with that minus sign in front of a parenthesis? Boom, boom. Yeah. So it becomes minus 5a minus 5. What about the other parenthesis? Well, there's nothing in front here. Right? There's no minus sign or anything. So we can just drop them. Nothing really changes. 5a plus 5h plus 5 all over h. Is that good so far? Now can we cancel anything?
Yeah.
5a and 5a. 5 and 5. 5h over h. Can we cancel those h's?
Yes.
Absolutely. There's no glue. There's no pluses or minuses anymore. Remember, that's the Costco thing we always have to be wary of, but they're gone. It's just 5 times h. We can totally just cancel those, and it's just 5. All that to be 5. There it is. Does that make sense? Yep. We just did the derivative is what it is, but it's a deeper story there, but that's all the story for now. So, yeah, that comes out 5. So let's try that on number 13. So I'm going to rewrite that one. What is it? 2x squared plus 3x. Do that one, number 13. Okay, so yeah, let's do it. So number 13, f of x equals 2x squared plus 3x. And then they're asking us to find f of x plus h minus f of x all over h, which is what we just did. We did it with an a, now we're doing it with an x, it's the same thing. So remember what a function is. These x's are really just placeholders. It's going to slide here, and and it's going to slide there, isn't it? So whatever you plug in is going to slide to those two places. So let's start with the first part here, f of x plus h. Let's just find him. What's f of x plus h? So take the function and put into the two holes in the toaster, the two x spots, parentheses, x plus h. So we'll get 2 parenthesis x plus h, 3 parenthesis x plus h. Is that good so far? See how I just plugged x plus h in the two x slots. So that's what the x's are in a function. They're holding spots. In fact, you'd be helpful to put blanks there. That's what they really are. Whatever you plug into the function, whatever you plug in there, it's just going to slide to those two blanks. So we plugged in x plus h, it slides to those two blanks. Now we just need to work it out, do some algebra here. So this means x plus h times x plus h, right? Whenever there's a 2 on a parenthesis, it means 2 of those. And the 3 needs to distribute, 3x plus 3h. Now, how do we do all this stuff here? Well, carefully. I'll leave the 2 sitting in the front. And you know, when you have two parentheses, you just do first to both, second to both. Remember that whole thing? So I'll take this first x to both, x squared plus xh, and then the h to both, plus xh plus h squared, plus 3x plus 3h. And then go ahead and let the 2 distribute. Right? This 2 is going to go boom, 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 boom. And so we get 2x squared plus 2xh plus 2xh plus 2h squared plus 3x plus 3h. You tracking with all the mess so far? Yeah. 2xh and 2xh, huh? So that'll become 2x squared plus 4xh plus 2h squared plus 3x plus 3h. Okay, now all of that is x plus h put into the toaster. Right? We put x plus h into the toaster and pop, all that stuff came out. All of this came out from the toaster. Okay, now back to the original question. What did they want us to do on this original question? Well, they wanted us to put x plus h into the toaster and see what comes out. We did all that stuff. And then subtract f of x and divide it all by h, right? That was the original question. I just did the first part. So what do we get when we do all that? Well, we already know we get all this stuff, so let me do that. This is what pops out. 4xh plus 2h squared. Sorry, I'm getting a little squiggly here. Got to be neat with this because it's a lot. 2h squared plus 3x plus 3h. That's all that pops out. And so that's the first group minus the second group. What's the second group? F of x, yeah. That's just the original. The original was f of x, wasn't it? So that's just going to be, parenthesis, this group, 2x squared plus 3x all over h. You see that? Everybody see what I did there? So do you see how this part here is f of x? And this part here is the f of x plus h. See how we've done what they're saying? We have f of x plus h and f of x, two groups with a subtraction in the middle, all over h. Okay, so now what? We're almost there. We just got to remove the parentheses. So we get 2x squared plus 4xh plus 2h squared plus 3x plus 3h. So we just drop the parentheses on the first one. Nothing changes because there's nothing in front of that parenthesis. But on the second one, the minus will distribute as we drop the parentheses. Right? Dropping parentheses is like letting a floodgate down and the water goes in, right? The negative sign goes in and hits everything. Minus 2x squared minus 3x. That negative distributes to both of them all over h. Now, is anything able to cancel? Let me give you a big hint. This is what I tell my calculus students. Whenever you're doing this thing called the difference quotient, every term on the top that doesn't have an h will cancel. If it doesn't, you messed up. That's a good way to double check your algebra, because it's a big mess, easy to make a small mistake. Every item up here that does not have an h with it will cancel. It's by design. So I'm saying 2x squared, that he doesn't have an h, he better cancel, does he? Right there. 2x squared minus 2x squared, gone. Now 4xh, he's got an h, he can hang around. 2h squared, he's got an h, he can hang around. 3x, he better cancel, he doesn't have an h. Will he? Yeah, there it is, 3x minus 3x. So it's a nice double check, it'll always work that way. All the terms without an h will cancel. All right, we're almost done. What do we have left here? 4xh plus 2h squared plus 3h all over h. Now, what do you do with that? They're all divided by h, aren't they? It's like the h is underneath all three of them. So it's going to cancel an h from all three, isn't it? It's going to cancel this h. It's going to cancel one of those two h's and that h. So what are we left with? 4x plus 2h plus 3. There it is. The difference quotient. So there's a mess of stuff.